Thank you very much for inviting me to this talk, and thank you very much for everyone to come to my talk today. I'm going to talk about a case study of how to correct selection bias in non-probability two-phase payment survey. The main focus of this study is about non-probability samples, which is different from most talks we had at this conference. But probability samples play a very important role in this case study. This is a joint work with Hung Chen from the Bank of Canada, and this work is financially supported by the Bank of Canada and MyTech through MyTech Accelerate program. The usual disclaimer applies. So let me start with the general setting of this case study. This case study involves a non-probability sample SNP from the Bank of Canada. So they are denoted in in this diagram as the colored circles, and probability sample from StatsCan, SP the black and white circle in the diagram. So the non-probability sample consists of two phases, as we can see the two concentric circles in the diagram. So every respondents of phase 2 comes from the first phase sample. So one thing I'd like to highlight is that the proposed method does not require the effort to identify overlapping units between the probability sample and the non-probability sample. When we estimate weights for phase 1, auxiliary variables x1k are available. The same set of auxiliary variables must be available in the probability sample as well. When we estimate weights for phase 2, auxiliary variables x2k include those from phase 1, x1k, and outcome variables y1k from phase 1. The sample selection mechanism for the non-probability sample pi1 and pi2 are not known for both phases. However, the design weights for the probability sample D are known. So we extend the single-phase pseudo-maximum likelihood framework from Chen et al. 2020 from JASA to our two-phase framework. This maximization problem of the pseudo-log likelihood function L star gives us the estimated selection probabilities in phases 1 and 2. The first line of the equation corresponds to phase 1, and it's exactly the same as the one from Chen et al. 2020, and the second line corresponds to phase 2. This equation performs data integration in phases 1 and 2. The essence of data integration is to borrow the strength from another data source. Specifically, in our case, in phase 1, we integrate phase 1 non-probability sample with the probability sample to benefit from its known from the known selection mechanisms of the probability sample. And in phase 2, we combine phase 2 data with phase 1 to benefit from the larger phase 1 size. Due to time constraints, the remainder of this presentation is going to focus on phase 2 only. So this flowchart summarizes the procedure we propose to estimate weights for our two-phase non-probability payment survey. So let's start with the blue box first. We start with phase 1 and integrate the first phase non-probability sample with the probability sample. The solution to the equation in the box phase 1's PML gives us a set of pseudo-maximum likelihood PML weights for phase 1, which is the inverse of the estimated phase 1 selection probability. So now we move on to the orange box. In phase 2, we combine phases 1 and 2 by the equation in the box two-phase PML and get estimated probabilities of being selected into phase 2 conditional on being selected into phase 1. So this is a conditional probability. So two-phase PML for phase 2 builds on phase 1 PML weights and is the inverse of the product of the two estimated probabilities. I'd also like to highlight that the expression for two-phase PML weights is analogous to the double expansion estimator for two-phase probability sample designs. So now we apply our two-phase PML to the 2020 Cash Alternative Survey of the Bank of Canada. So in this survey, phase 1 is a survey questionnaire, and phase 2 is a diary survey instrument. Here we face an issue. In phase 2, young people of ages 18 to 34 are hard to reach. The response rate of this age group is lower than other age groups, as we can see from the table. And this low response rates give rise to larger selection bias for this age group. And this low response is clearly correlated with age group. So as a form of missing a random, two-phase PML can directly address this observable selection bias by explicitly incorporating this characteristic into a parametric model of selection probability. On the other hand, we are working on how to address the unobservable selection bias by using paradata. So we conducted a comparison and found that two-phase PML is more effective than breaking to reduce the selection bias in the low response age group 18 to 34. This comparison involves a benchmark, and this benchmark we use is the mean cash on hand estimated from phase 1 PML weights. And we have validated this set of weights by comparing estimates of 8 variables about online shopping behavior of Canadian adults during COVID-19 from phase 1 and a probability sample from StatScans, which is called CPSS5, is the Canadian Perspective Survey Series 5, at both the overall level and the age group level. Here we validate phase 2 PML weights in the same spirit by comparing the benchmark with the estimates from two-phase PML and phase 2 only ranking. So this chart shows that the difference from PML is very small, is 6 Canadian dollars, around 3% away from the benchmark, and for raking is about 70%, much larger. So from here, we can see that two-phase PML can be more effective than raking to reduce selection bias. So in summary, integrating probability survey sample with non-probability survey sample was useful in reducing selection bias in our case. PML needs an individual level probability sample, but raking, the traditional method, requires only aggregates from the probability samples, or we take values from the census. But this higher data requirement for the PML should not be an obstacle to using two-phase PML instead of raking, because a wide range of quality individual probability samples are available online. For example, in Canada every month, StatsCan releases the public use microdata file of last month's labor force survey. The access of this file is free of charge, it's online, everyone can download it from their website, and they have a pretty good release schedule about when they will release the file. The labor force survey has lots of useful auxiliary variables, such as employment status and whether the individual has a tenure for their job. Therefore, we see the potential of using PML, pseudo maximum likelihood for two-phase non-probability payment survey instead of raking for weight estimation. So thank you very much for your time, and thank you to the organizer for covering the travel costs and hotel accommodation, and for their excellent organization of this conference. Thank you very much.